Now I gotta repeat that whole thing. No.
So sad.
No.
They just won't forget.
So, let's go into this question. What is a radian? Get ready to draw. Draw a circle. That's R for radius. Ooh, let me see if I can do something really cool. That was the center, right? About? Does that look like about the center? Is it a little off? Maybe it's a little off. Ooh, that right. That is dead center. That is dead center. No, you guys' eyes are off.
No, your eyes are off.
Okay, so start in the middle.
That's tall. That's not straight.
What? Look again. So you guys would agree that's one radius, correct?
Yeah.
Okay, now I don't know if this is gonna work, but I'm gonna try. Ooh, this is gonna be awesome. So I'm gonna take this and oh, I don't know if this is gonna work. I've got to rotate it. Rotate it. There we go. That's the same distance as that radius. You guys agree?
Yeah.
I just rotated it up. I'm going to take this and put it right there. Now, if I start at the center and measure the outside, that's one radius, correct? This length that's going up like that, that's one radius. If I were somehow able to take this length that's vertical and wrap it around the edge of the circle, that's what I'm getting at here. That's what I'm trying to do. It's not working too well. But if I took this length right here and wrapped it around the edge of the circle, where would it go? About how far would it go around? So if I, maybe till about here. You think it'd go a little farther?
Yeah, a little bit.
Maybe about right there. So the point here is, even though that line is curved now around the outer edge of the circle, isn't it the same distance as that original? So if from here to here was R and from here to here was R for radius, then how far is it from here to here? R. That's still R. Would you guys agree? It's an R. Let me fix that. That's an R. Now, let's finish this off by actually making it an angle. That's one radian. The measure of this angle formed right here, the measure of that is one radian. The point of this little discussion or illustration is, what is a radian? Well, a radian is a measure around the outer edge of a circle equal to the radius of that circle. Okay? Hold on a second. Isn't this the measure around the outer edge of a circle? What's the length of this blue measurement right here? That's equal to the radius. So a radian measure is the length around the outer edge of the circle that's equal to the radius of that same circle. Now, let me show you maybe a better illustration of this. Hold on a sec. No. So here's a little dynamic illustration. It actually moves. What is a radian? Check this out. Watch the circle. Okay? So there's one radius, right? That radius gets, whoa, wrapped around. The measure of this is equal to 1 radian. Huh? Let's start making some connections to what you're more familiar with, degrees. How many degrees are there in a full circle? Only 2 of you knew that? Come on. How many degrees are there in half of a circle? I want more than just 2 people to answer that one. 180, right? We're really familiar with degrees. My question to you is, how many radians are there in half of a circle? If I put my mouse right here at the half circle mark, how many of these radian measures do you think we can fit into there? 3. You think 3?
Yes.
Take a look. 1 radian goes from here to here. A second one would go into about here. A third one, maybe 3. 3 is a pretty good guess. Look carefully, though. You watching? There's 2. There's 3. Did 3 radians make it quite to half of a circle? All right. 1 radian, 2 radians, 3 radians, plus a tiny bit more is half of a circle. Does anybody know a very famous number that's 3 plus a tiny bit more?
5.
What number is that?
5.
It's pi. A half a rotation. We already knew it was 180 degrees, didn't we? But now we're talking about radians. What's half a rotation in terms of radian measure? 3.14 or pi radians. Yeah? That circle that you guys drew on your notes, off to the side, I want you to write this. Half a rotation equals 180 degrees. That's also equal to pi radians. Ooh, tricky question for you. As you're writing, I want you to think about this. If half a rotation is pi radians, then what's a full rotation?
It
6.28, which would be 2 pi. A full rotation is 360 degrees, or 2 pi radians. You need to write especially the half rotation. 180 degrees, pi radians. So you could use like 6 radians, 7.
No, there'd be 6 radians, and then the 2.8 would be the 2 slivers put together.
So the question was, would 6 radians go all the way around a circle?
No, one and go that way. Then 3 more.
It'd make it till about right here, and then you'd have a little bit more to go. So we need to talk about how to convert back and forth. If I give you something in degrees, how do we know what it is in radians? Or if I give you something in radians, how do we know what it is in degrees? And this is what I was talking about for those that are in a chemistry class. You've already done some of this. Those that aren't in a chemistry class, that's all right. It's called unit analysis or dimensional analysis. You need to start writing. We're going to practice with some measurements you're more familiar with, like inches to miles or seconds to hours, things like that. We're going to practice converting back and forth between those. That will hopefully help you be more comfortable converting between degrees and radians. No, that's too easy of a question. I'm going to change that question.
Supposed to write this question down.
I want you to write this question down. 4,628 seconds is how many hours? If I said, all right, I want you to count 4,628 seconds, how many hours would that take you?
Cool, 30 seconds, 60 seconds.
Whoa, whoa, whoa. So 4,628 seconds. What we need to do is multiply this by a fraction. It's called a conversion factor, The key to this conversion factor is it's the same thing divided by itself. Why does it have to be the same thing divided by itself? What is something divided by itself? 1. Okay? And if I take this number and multiply it by 1, am I changing the value of the number? No. What we are going to change, though, is the unit of measure. The key to this is you end up with something that's numerically equivalent, just measured differently. Okay? So we need to multiply this by something divided by itself. We have to be a little bit clever about this. Okay? How many seconds are in a minute? So would you guys agree with this, that 1 minute is equal to 60 seconds? Is that true? 1 minute is equal to 60 seconds?
Now, didn't I just tell you had to multiply this by something divided by itself? Does that look like something divided by itself?
No. Let me erase it.
It doesn't look like something divided by itself, but isn't it really something divided by itself? Isn't 1 minute and 60 seconds the same thing? So what is 1 minute divided by 60 seconds? What's the value of 1 minute divided by 60 seconds? It's just 1. Okay? Now, notice the order I put this in. Why did I put 1 minute over 60 seconds and not 60 seconds over 1 minute? Because that would have been the same thing, 60 seconds over 1 minute. True. What is it we're trying to cancel? Seconds. I want to cancel seconds, so I put that on the bottom. So since we're dividing, now we're in terms of, what are we in terms of? We're no longer in terms of seconds, we're in terms of minutes. But what was the question I asked? How many hours? Now we're in terms of minutes, so we're closer. I need to multiply this by one more conversion factor.
Minutes over hours, so 60 minutes equals 1 hour.
But what is it I want to cancel?
1 hour. You want to cancel minutes.
I want to cancel minutes. So where does minutes have to go on my conversion factor? On the bottom. I have to put minutes on the bottom and hours on the top. 60 minutes makes 1 hour.
We don't know. We plug in.
Now the minute unit of measure canceled. Those few of you that said you were taking a chemistry class, is this some of the stuff you did in chemistry?
Isn't it just the same as the Radian train chart, except those lines are just all the way across?
Yeah. Yeah. So how do we answer this question?
Multiply everything on top and divide it by what's on the bottom.
Multiply everything on the top. So it's 4,628 multiplied by 1 multiplied by 1, which makes 4,628. And then we divide it by everything on the bottom, which is 60 times 60. That would be 60 plus. We need 60 multiplied by 60. It's 3,600. 3,600. So 4,628 divided by 3,600.
16,660,000.
But did you divide or multiply? We got to divide. It should be something just greater than 1, just slightly greater than 1.2. So doesn't 4,628 seconds seem like a long time, but in reality, just a little over an hour. Okay, good. That's good. Let's try another one. One more real quick. 4.6 miles. is how many inches? If I wanted you to count how many inches there were in 4.6 miles,
So we would do miles to feet, or miles to yards, which is also feet, and then we would do feet to inches.
that's what I would do. I would go miles to feet, feet to inches. So 4.6 miles needs to be multiplied by a conversion factor, and it's the miles that I'm trying to cancel. So on my conversion factor, where does miles need to go?
Bottom.
Bottom.
Wait a minute. How many feet go to mile? 5,000?
5,280 feet are equal to 1 mile.
And then 5.
But now we're in terms of feet. I want this in terms of inches. So we need one more conversion factor here.
So we turn feet to inches with 12 feet.
Where does the feet need to go?
Bottom.
1 foot is equal to
12 inches.
12 inches. So now the feet unit of measure cancel. The only unit of measure that's left over that hasn't been canceled is inches. So we're in terms of inches now.
So you would do 4.6 times 5,000 times 12.
Yep.
And then you would do that divided by feet.
Well, it's divided by 1.
291,456 inches. Thank you.
How would you get that?
It's over 1.
You don't need to divide it by 1. Just multiply everything straight across.
No, you don't divide by 3. It's just 1.
Dividing by 1 doesn't change anything. This is just called dimensional or unit analysis. You do a little bit of this kind of stuff in chemistry and physics. The reason I'm having you practice this is exactly how you change degrees to radians. Check it out. Convert to radians. Write down 60 degrees. We're going to change 60 degrees. Whoa, where'd you go? We just lost it. There it is. We're going to change 60 degrees into radians. The key to this, you guys, if you haven't written it down, write it again, or maybe you should write it again anyway just to help. The key to this is 180 degrees is how many radians?
Pi radian.
Pi radians. This is the key that makes this all work. This is actually your conversion factor. 180 degrees is the same as pi radians. Just like 1 foot is 12 inches or 60 seconds is 1 minute. All of those conversion factors, it's a similar thing that we're using here. So the important thing is what unit of measure are you trying to cancel? That's what we have to decide.
We're trying to get out of degrees into radians. So if I want to cancel this degree, then on the conversion factor, where does the degree
Measurement have to go.
Follow.
It's got to go on the bottom.
So,
And what goes on the top? Pi. Radians.
I want to stop here for just a second to make sure we're on the same page. What is pi radians divided by 180 degrees? What is that? Pi radians divided by 180 degrees. It's just 1, because pi radians is the same as 180 degrees. I'm taking 60 degrees and multiplying it by 1, essentially. That's why this works. What's 60 degrees multiplied by 1? 60 degrees. So I'm not changing the size of the angle. All I'm doing is changing how it's being measured.
Instead of degrees, we're going to measure it in radians. Now, if the degree here is on the bottom and there's 1 on the top, then the degree symbols cancel. We're no longer in degrees anymore. What are we now in? We're in radians. Now you multiply straight across. 60 times pi is just 60 pi radians divided by 180. simplify the fraction. 60 divided by 180. We need to simplify this fraction in front. 60 divided by 180. I was kind of shocked at my last class on how unprepared they were to simplify simple fractions like this. It kind of set me back a little bit. 60 divided by 180, that's a pretty easy fraction to simplify. What'd you get? It is pi thirds. Pi, yeah, pi. How do we go from 60 over 180 to pi over
60 goes into 8.80 times.
60 goes into 180 3 times. If at this point you are still struggling to simplify fractions, you might as well just do it on a calculator.
So what's 6.14 over 3? Would it just be 4?
No, you leave it as pi over 3. Just leave it as pi over 3. Let me show you real quick how to do, I guess if you have one of these kind of calculators, you can type in 60 divided by 180, hit the math button, the first option that pops up is fraction, so hit fraction, and it simplifies it to 1/3.
But then you get pi is the
But then there's pi, so it's 1 pi over 3, which is just pi thirds. It's pi over 3 what? Degrees or radians? It's pi over 3 radians. Now, you guys, nobody ever writes out the word radians. Okay? The absence of a degree symbol implies that this is already in radians, so you can just leave it as pi over 3. Did you all hear what I just said? The absence of a degree symbol automatically means what? Radians. If there's a degree symbol, it's in degrees. If there's not a degree symbol, it's in radians.
Why don't you put 60?
Because we didn't want 60 degrees, we wanted pi over 3 radians. Okay? Here's something else to consider. You don't necessarily need to draw this, but 180 degrees, that's half of a circle, right? 60 degrees would be about right here. Isn't that just a third of half of a circle? You guys follow? Here's 180 degrees. Isn't 60 1/3 of that? So if 180 degrees is also the same as pi radians, and if 60 degrees is a third of 180, then wouldn't pi over 3 be a third of pi?
Yep.
60 degrees is the same as pi over 3 because 60 is 1/3 of 180. Anyway,
So if it says 112, it would be pi over, it would be 2 pi over 2.
say that again.
So say you're trying to find, instead of 60, you're trying to find 120 degrees, you're trying to turn it into pi radian.
That would be 2 pi over 3.
So how would you write that?
2 pi over
2 pi.
Let's try this one. Whoa, quit looking at the answers.
Quit showing up to us.
45 degrees. Convert 45 degrees. Convert 45 degrees into radians.
Remember, you have to end up with a simplified fraction.
So,
Wait. Oh, so would it be pi over 4?
that's what Michael has, pi over 4. What do you guys think? You got pi over 4? Anybody else?
I didn't need it.
Is this correct?
I think so.
180 degrees over pi like that?
I thought it was the other way.
That's what I wrote.
Would it work this way?
No.
No.
I think that's the one. Oh, that's
Why does 180 have to go on the bottom?
because we're trying to get rid of the
We're trying to cancel out that degree symbol.
Degree.
Yeah. So this turns into 45 pi
Over 180.
over 180.
And 45 goes to 184.
45 goes into 184 times, so this is pi
Over 4.
over 4. Any questions on degrees to radians?
How'd you get
45 divided by 180. 45 is a fourth of 180. That's 1/4. Do you have your calculator?
No.
Type in 45 divided by 180. And then hit math. Does yours have this little math button? So turn it into a fraction. It's 1/4. So that means it's 1 pi over 4 or pi 4. Let's go the other way now. What if it's already in radians?
You would put pi on the bottom.
So what about something like 5 pi over 6?
You would write parentheses pi over 180. It would be 180 over pi.
So say that again, Michael.
180 over pi.
What do you guys think? Now we flip it around and do 180 degrees over pi radian.
Are we converting?
We're converting 2 degrees. So we want that little pi symbol to cancel. If I want pi to cancel on 5 pi, then on my conversion factor, pi has to be in the bottom. So the pi symbols cancel. And then how do you figure out the rest of that? It's basic arithmetic from here on out, pretty much. 5 times 180 and then divided by 6. Pretty easy to do. Here's actually what I would do if this were me. You can multiply and divide pretty much in any order. You could do 5 times 180 and then divide it by 6, or for those that are a little more comfortable doing mental math, and you have to be good at doing mental math, not just say, oh, I can do it here and there. How many times does 6 go into 180? What's 30 times 5? 150. The answer is 150. Okay. If you're a little nervous about doing mental math, then don't do mental math. Use your calculator. Type in 5 times 180, hit enter, and then divide it by 6. And it still gives you the same answer, 150. Yeah. Yeah. So it's 150 degrees. No, we're not quite done. We're done with the first couple. Take a look at problems 1 through 8 on that golden colored worksheet I just handed you. The first 8 questions, you're just converting back and forth. If it's in degrees, put it in radians. If it's in radians, put it in degrees by either using pi over 180 or 180 over pi. Let's take a few minutes to practice this. 5 times 180.
Was that 5?
It's 5 right here. 5 times 180 and divided by 6. This, so you don't get confused, please listen carefully and take good notes on this. Yeah, not mediocre notes. As you're writing, I'm going to talk here a little bit. We've already talked about arc measure. We've talked about arc measure, which is different than arc length. Arc measure is different than arc length. Here's what I mean. This was 2 assignments ago, which I think that's when the sub was here. Wasn't there a sub 2 times ago? And you guys had an assignment that you claimed didn't make any sense. Remember that one?
Yes.
On that assignment, we talked about central angles. Take a look at where this is. Isn't this a central angle? Does that phrase sound familiar, central angle? Okay, the key, or the point of that part of the lesson was, if we knew, I don't want you to change anything in your notes, but let's say, for example, we knew that this was 60 degrees. Then what was the measure of that arc? Then the measure of that arc was 60 degrees. Right? Remember that?
Yeah.
Yes.
That was from that lesson 2 times ago. A central angle is equal to the measure of the arc. Notice how I'm saying measure of the arc. Measure is different than the length of the arc. Okay? So, oh, by the way, just by means of review, what was it called when the angle was on the outer edge? Remember what that was called? Inscribed. This is just review, but I need you to look up here for a second. This is what we talked about last time. This angle right here, isn't this an inscribed angle? So what if I told you this was 20-degree angle? Then the measure of the arc is 40. Okay? That's called arc measure. Arc measure is just some kind of a degree that has to do with the angle. But arc length is more closely related to radians, not degrees. So from here to here, that's called an arc, right? Now, for some reason, I don't know why they chose to use this letter, but the length of an arc, for some reason, they decided to call that S. Arc length, the variable they chose to represent that is S. I don't know.
I think there's time for X's and Y's.
Probably. Okay, listen carefully. An arc measure is equal to the central angle, but an arc length is an actual measurement in inches or yards or feet or whatever it is. An arc length is a measurement that you can measure with a tape measure. Okay? So it depends on the unit of measure of the radius. If the radius is in inches, then the arc length is going to be in inches. If the radius is in miles, then the arc length is going to be in miles. Okay? And arc length is an actual, this, for example, if we were able to stand on this circle and walk from this point to that point, how far would we have walked? That's the arc length. Okay? It's not how many degrees around the circle did we go. That's the arc measure. It's how far did we actually walk. That's arc length. Here's the formula. It's a pretty easy formula. S. What does S stand for? Arc length. S is equal to R. What is R? The radius times the angle. That's all it is. It's the radius times the angle. It's pretty easy. Arc length. That's a theta. That's the measure of the angle. But here's where students go quite wrong. Put a little star by this theta symbol. Theta must, and underline must, be in radians. Take a look at question 9 on your assignment. Do you see how I give you an angle measure? What's the problem with that angle measure?
It's in degrees.
It's in degrees. You can't use this formula then.
Go just like switch it.
That's, yeah, exactly. That's why we just practice converting degrees to radians. So on number 9, 10, and 11, you're not going to use this formula first. What are you going to do first on all 4 of those? Convert the degrees into radians, and then use this formula. Okay? Let's practice. Here's an example.
So it's going to be degrees equal to feet miles. Does that make it
I want to convert, or I want to find the length of this arc right here. Two things we have to know in order to find this arc length, S. We have to know the radius, and we have to multiply that by the angle. We know both of them. We know the radius is 9. Now, the angle is 135 degrees, but that's no good for this formula. It has to be in radians. So, before we even use this formula, 135 degrees has to be converted. 180 degrees, and pi has to go on the top. So it's pi over 180. Degree symbols are gone. So it's 135 pi over 180, and then you have to figure out what 135 over 180 is. And it's 3/4. So this turns out to be 3/4 pi, or 3 pi over 4. Is that the answer? Is that the arc length? That's just to measure the angle in radians. That's theta. Theta is 3 pi over 4. What do we do with theta? Plug it into the formula now. S is equal to 9 inches, or just 9 times 3 pi over 4. So it'll be 9 times 3. Let's do this in pieces here. What's 9 times 3 pi?
We have to put the pi.
It's 27 pi over 4. Now the only thing that you do here is if that fraction simplifies, then you simplify. If not, just leave it alone. Does 27 over 4 simplify? No. So that's your answer. Well, not necessary. What's the unit of measure? Inches. So it's 27 pi over 4 inches. That's the length of the arc. So let me help you with number 9. So this is number 9. The radius was, what did you say it was? 12 miles. And then, whoa, I didn't want to do that.
That's crooked now.
No, it is a little crooked. That's not even a center anymore. Ugh. Not bad.
Still crooked.
That's better anyway. What was the measure of the angle?
120.
120 degrees. All right, and you're supposed to find the measure of the arc from here. So yeah, the length of that arc.
So it's going to be 120 degrees.
So we're going to use the formula S, or arc length, equals radius times theta, and it sounds like a lot of you are getting it. 120 degrees needs to be converted into radianism. Pi over 180. Degrees are gone.
That's going to be 125 over
So it's 2 pi over 3. So now we use the formula. S is equal to the radius, which is 12, times the angle, 2 pi over 3. This one actually can simplify a little bit more. 12 times 2 is 24, but 24 divided by 3 is 8. So S is equal to 8 pi miles. It's a pretty big circle. Or arc. That's how 10, 11, and 12 work. First you convert
12, 13, 14, 15, 16, the same. All you're doing is plugging it in, right?
I don't know, turn over to the back. I don't know if the back side's absolutely the same or not.
I know 17 through 20 will be what we're doing now, but you don't have to solve anything.
Take a look at 13. What's the only difference between 13 and the one I just showed you? Yeah, there's no picture, there's no diagram. Do you still have a radius?
Yes.
Yeah. Do you still have an angle?
Yes.
Yeah. What do you still have to do though with that angle?
Make it into radian.
You gotta make it into radians. So 13 through 16 are all pretty much the same as number 9. You can draw your own picture if you want. Now, okay, 14 is a little different. Let me help you guys. Let me help you guys with 14. 14 says find the angle measure of the arc. I've given you a radius of 4. I mean 17, not 14. Sorry, 17. I've given you a radius of 4 feet, and I've given you S of 10.8 feet.
You solve it as equals r times theta.
All I'm asking is find the angle measure. The angle measure is theta, isn't it? That's an angle measure, theta.
So it'd be 10.8.
So the formula is S equals radius times theta. What is it I'm asking you to solve for?
Find theta.
Find theta. How do you solve for theta in this equation? How do you solve for this theta right here? Solve for it means get it by itself.
So you would divide r by s.
Divide by r on both sides. So S divided by r is equal to theta. This is actually a pretty easy problem because don't I give you S? And didn't I give you r? So how do you find theta? Just divide. It's okay. It's a decimal. That's how, what number was that? 17?
Through 20.
That's how 17 through 20 work. Theta is equal to the arc length divided by the radius.
And then 21 to 24 is find the area for each.
21 to 24 is a different objective altogether. I would really like to give you more time to work on this, but because it's short day,
We'll just do that.
we really don't have time to let you work. I need you to get back to your notes. This is a new topic. Normally, if we had a full class period, I'd let you work for about 10 minutes, and then we get back to it. We just don't have time for it today. So get back to notes. This is our last topic for this lesson. The area of a sector. We've talked about arcs, we haven't talked about a sector. So, draw this picture. A sector is just a portion of the inside of a circle. The whole entire inside is the area of a full circle. What's the formula for that, by the way? Does anybody remember what the area for a full circle is?
360.
The area formula for a circle. Pi r squared. You have not heard of that formula ever?
No.
Pi r squared? Anyway, that's the area for an entire circle. We're talking about just a portion of it. That's what a sector is. A sector is a portion of the inside of a circle. As long as the angle is a central angle. Some students get confused with what a sector really is. I don't want you to draw this, well, maybe just so you can compare. This right here is a sector. This right here, this little piece, isn't that still the portion of the inside of a circle? Why is this not a sector? Yeah, the angle is not a central angle, so this is not a sector. A sector has to have its angle in the center of the circle. It's not quite an easy of a formula to remember. Here it is though, area or A for area, is equal to 1/2 times the radius squared times the angle.
So
Area is equal to 1/2 radius squared times the angle. But again, what must be true, do you think, about this angle?
that must be in the radius.
Has to be in radians. That angle has to be in radians. So here's an example. We'll do this one, and then I'll help you with the first one of that section, number 20 something, 21. I'll help you with number 21, but let's get through this one first. We'll do this example, then I'll help you with 21. So I want you to find the area of this sector that I've shaded in. It has a radius of 14 feet. And a central angle of 300 degrees. This little piece here would be 60, yeah. But I want you to find the this area with 300 degrees. So we are going to have to use this formula, but we can't use theta equals 60. 300. We can't use theta equals 300. We have to use its radian measure. So first thing is convert 300 degrees to radians. So it's pi over 180. The degree symbols are gone. And it would really be nice or faster if you could start simplifying these in your head. If they both end in zeros, you can cross out the zeros as well, and now you're just simplifying 30 over 18. Let's have the 30 and half of 18. 15 over 9. Now we'll have, how much farther can you go? Wait, 15 over 9? You can divide it by 3. So it'll be 5 over 3. 5 over 3. So it's 5 pi. The measure of the angle is 5 pi over 3. Now we use the formula. Area is equal to 1/2 times the radius, which is 14, so 14 squared, times 5 power 3. And you multiply everything straight across. This really is a fraction. 14 squared is the same as 14 squared over 1. Multiply everything straight across. Top to top, bottom to bottom. Let's start on the bottom. That's the easier one here. 1 times 2 times 3. So we're going to have a 6 on the bottom.
So 1 times 4, 1 times 14 is 14.
You have to square it first. So, yeah, 14 squared. Then you times that by 5. And then you times it by pi, so it's 980 pi. Now, how do we know that that can simplify? That can simplify.
Just 2 can go into
2 goes in. They're both even.
well, 3 can go into 140. Right?
Well, 3 can go into 6. Wouldn't it? I don't know if 3 goes into 980. I don't think it does. 2 goes into both of them. What's 980 over 6 as a simplified fraction?
So 490. Yeah, it'd be 4.
It'd be 490 pi all over 3. But these have to have a unit of measure. It's feet. Now, when you guys are talking about an area, like the area of this room, how do you describe an area? It's in square footage. If you talk about the area of a home, don't they always talk about square footage? We're talking about the area of a figure, so it's not just feet, it's feet squared. It's square footage.
That's the answer.
So it's 490 pi over 3 square feet, or feet squared. So real quick, before the bell rings, we have a little bit of time. Let's help you with 21. So it's a circle. We have 12 yards, and the angle here is 270 degrees, and they want this sector right here. This is number 21. So we need to use the formula. Area is 1/2 times the radius squared times the angle. As long as we can get the angle in radians, then we can use that formula. 1/2 times the radius squared times the angle. So the first task should be 270 degrees. Convert that into radians. So it's pi over 180. And then you can cross out the zeros, divide them both by 9, because 9 goes into 27 and 18. So it would be 3 pi over 2. So it would be 1/2 times 12 squared times 3 pi over 2. So the 12 squared is 144. 144 times 3
That's 1,432.
is 4332.
You did 1,400.
Holy moly!
It's
1,144
430.
times 3. There we go. 432. So we have 432 pi all over 4.
Divided by 2.
That divides evenly?
Yeah, 1.
Sweet. So that's equal to 108 pi what? Yards squared. Now, just real quick to wrap this up, I know it's a bit of a stretch, but I want you to think about a possible practical application of this. Have you guys ever been up hiking on Tip and then looked out over the Utah Valley, specifically over here in Saratoga Springs? You notice the shape of all of the farm fields over here? What's the shape of those big fields?
Circles.
They're circles. Okay? When they start talking about watering and how much it costs to plant and water their crops, they're talking about portions of circles and arc lengths and sector areas and things like that. So there is a little bit of there.